Today I will be discussing vitamin D3. So a little bit of background. Vitamin D3 is produced by the skin upon exposure to the sun. It can come from animal sources such as liver and fish oil. It has similar effects to steroids due to its structure, which allows it to function as a fat-soluble hormone that can cross the blood-brain barrier. A deficiency in this vitamin is common throughout the world and it can have impacts on brain function. Higher levels of vitamin D3 appear to be protective, while a deficiency has been linked to a cognitive decline that is associated with neurological diseases such as dementia. Vitamin D receptors are spread throughout the body and the brain tissue. Both vitamin D2 and D3 need to be converted by the liver and the kidneys into the form of vitamin D that is used by the body. Vitamin D3 is only found in animal-sourced foods, whereas D2 comes from mainly plant-sourced foods and fortified foods. Vitamin D3 is also much better at raising overall vitamin D status in the body than vitamin D2 is due to how it is metabolized in the liver. Therefore, vitamin D3 is the best form of vitamin D to supplement as it is absorbed better. This image shows how vitamin D3 is produced, metabolized, and used in brain function. Some of the roles it has in maintaining brain function include cell differentiation, neurotransmitter synthesis, maintaining calcium homeostasis, and playing a role in maintaining cognitive function. The first paper I will discuss is vitamin D in synaptic plasticity, cognitive function, and neuropsychiatric illness. It discusses the role vitamin D plays in brain physiology and how it helps regulate brain plasticity. Vitamin D deficiency affects synaptic plasticity and can impair cognition. However, the molecular mechanisms behind this are poorly understood. It can impact synaptic plasticity by affecting L-type voltage-gated calcium channels and the regulation of various neurotransmitters, including nitric oxide. A deficiency may also weaken aggregates of the extracellular matrix. Dysregulation of extracellular matrix structures in the brain may contribute to cognitive deficits. Understanding molecular mechanisms through more research can help treat cognitive impairments in patients who have schizophrenia or other neuropsychiatric illnesses. The next paper I will discuss is the potential role of vitamin D in the elderly to resist COVID-19 and to slow the progression of Parkinson's disease. Vitamin D3 may be an option in reducing the risk of COVID-19 and slowing the progression and improving the quality of life for elderly people with Parkinson's. The elderly are more likely to be diagnosed with Parkinson's disease and develop COVID-19. They are typically have a low normal to deficient vitamin D3 level in their body. The conclusion reached by this paper was that daily vitamin D supplementation has the potential to slow progression of Parkinson's in older adults with Parkinson's, and also offer protection against COVID-19. Parkinson's affects motor and cognitive function, and it is marked by neuronal cell death and substantia nigra. Therefore, it reduces dopamine synthesis, causes tremor, postural instability, and rigidity. Vitamin D3 receptors are found on dopaminergic neurons in the substantia nigra, which is often degenerated by Parkinson's. Supplementing vitamin D for patients with Parkinson's, especially for individuals with lower baseline levels of vitamin D3, may protect dopaminergic neurons and their receptors. Animal models have shown this neuroprotective property, but clinical trials are necessary. Individuals with Parkinson's also tend to have impaired motor functioning, postural instability, and balance difficulties, so falls may be more common. Vitamin D plays a role in maintaining calcium homeostasis, and low vitamin D impairs calcium homeostasis, leading to an increased risk of bone fractures or injuries from a fall and osteoporosis. Therefore, vitamin D supplementation may help improve bone health. Studies have also shown that higher levels of vitamin D3 are associated with improved verbal fluency and memory, which can improve cognition and memory as well as mood. Therefore, supplementation may improve the quality of life for patients with Parkinson's. Now I'll be discussing the potential antiviral property of vitamin D. It plays a role in both the adaptive and innate immune systems and has antiviral properties, including protection against infections and respiratory illnesses. Some of the mechanisms of action behind this include increasing capillary permeability to help deliver inflammatory mediators to the site of infection. Activating its receptors also induces invariant natural killer T cells, forming a bridge to the adaptive immune response. Many illnesses, including COVID-19, have the potential to lead to immune system dysregulation in a cytokine storm caused by a pro-inflammatory state. Binding of vitamin D to its receptors can lead to changes in gene transcription, which may downregulate pro-inflammatory cytokines and upregulate anti-inflammatory cytokines, preventing the severe complication related to COVID-19 and other viral illnesses. Vitamin D3 may also have antioxidant properties as well as the ability to increase telomere length and DNA stability. So what are the implications of this? The benefits of vitamin D3 supplementation tend to be the most noticeable with longer-term supplementation opposed to short-term supplementation. Vitamin D may help aid immune responses to vaccination, a factor that is critical to consider when vaccines are being developed against COVID-19. Past studies, however, have had mixed results when it comes to vitamin D's antiviral properties, but many studies have actually found that there have been reductions in illnesses, development, duration, and severity in relation to adequate or enhanced vitamin D levels. More research is necessary on the relationship between vitamin D and the ACE2 receptor and how this may affect COVID-19 risk and pathogenesis due to contradicting studies. ACE2 is an enzyme on the surface of many cells and tissues, including epithelial cells. The virus that causes COVID binds on this receptor and can enter and infect the cell, which leads to the downregulation of this receptor. Vitamin D may also increase levels of ACE2, which is why it may be beneficial. This diagram shows how a deficiency in vitamin D can lead to increased risk for illnesses and diseases, including conditions related to COVID-19. As you can see in the diagram, a deficiency may lead to a downregulation of the ACE2 receptor, which can increase the susceptibility to infection and also lead to lung injury and many other implications as well. And these are my references.